Okay, so we're going to do some electricity past paper questions. So first question, when a balloon is rubbed in your hair, the balloon becomes negatively charged. Explain how the balloon becomes negatively charged. Okay, so I'm going to draw a diagram. Here's my balloon. Okay, when you rub it on some hair, okay, it becomes negatively charged. So if you think about any type of atom, okay, you've got a positive nucleus with protons and neutrons, okay, protons are positively charged, and then on the outside you've got negative electrons. Now the electrons are roughly 2,000 times lighter than the protons and neutrons in the middle, and they're actually quite far out from the center of the atom, and also they're on the outside of the atom. So what's most likely to move, what particles most likely to move when you rub surfaces together are the electrons rather than the protons. Okay, so what actually happens when you rub surfaces together, the light electrons are the particles that move and the positive protons are the particles that stay, and that is what gives the difference in charge. So in this case, before the hair was rubbed with the balloon, it would have had equal positive and negative charges, on each hair strand. However, when the balloon rubbed against the hair, the negative electrons from the hair must have got on to the balloon. Okay, the clue is in the question because it says explain how the balloon becomes negatively charged. Okay, so we're going to say 1A part 1, the negative electrons from the hair pass on to the balloon. Okay, and that makes it negatively charged. Next question, state what you know about the size and sign of the charge left on your hair. Okay, so the sign of the charge left on your hair will be positive, and the size will be the same as the electrons that have left. Okay, so that essentially is what it means by the sign and the size of the charge left on your hair. Okay, so what it means is for every positive charge, okay, that's 1 plus, it balances out with 1 minus of an electron. Okay, so the size is +1 is 1, and the size of the electron is a 1 as well, but they're opposite charges or signs. Okay, right, next question. The negatively charged balloon is brought up to the surface of a ceiling. Okay, that's the top wall in a building or the top layer in a building. The balloon sticks to the ceiling. Explain how and why this happens. Okay, so now here is our ceiling. Okay, we move our negative balloon, okay, upwards like that. Okay, basically what is going to happen here? Okay, at this moment our positive and negative charges are equal, are located like that, or are positioned in that way. However, I draw this again, when I move the balloon closer to the ceiling, what happens now is these negative electrons are going to be pushed upwards, leaving the positive charges, which don't move at all, there, and basically the positive charges here attract the negative charges here. Okay, so that electrostatic attraction between the two charges causes the balloon to stick to the ceiling. Okay, so the balloon pushes the negative charges in the ceiling upwards, resulting in an excess positive charge which gets attracted to the negative charges on the balloon. Okay, so that's the answer to that question. Right, next question. It says, spraying crops with insecticides has become more efficient. A portable high voltage generator gives the drops of liquid insecticide a small positive charge. This makes the liquid break up into smaller drops and causes the spray to become finer and spread out more. The plants, which are all reasonable conductors, are in contact with the earth. As the droplets of spray get near the plants themselves become slightly charged and attract the droplets. Okay, explain why the positive charge on the droplets makes the spray spread out. Okay, so essentially, what do we have here? We've basically got here's the end of the spray. Okay, maybe it looks something like that. Now, and out come the insecticide droplets. Now, at some point before they leave, okay, this the end of the spray, they get charged. Okay, and they get charged like that, so that they end up all positive. So their electrons get removed, and what happens is basically we know that positive charges, okay, repel each other. Okay, so a negative and a negative repel, and a positive and a positive repel. So what does that mean? It makes the droplets spread out. So that's the answer to that question. So due to each droplet being positive, they repel each other. Okay, so that's the answer to that one. State what charge appears on the plants as the droplets come near to them. Okay, so basically what's happening here. So we're having, let's say this is a plant, okay, it's a leaf. Right, so we've got positive droplets. Now obviously I've enlarged these purposefully so that you can see the positive signs in the droplets. Okay, these are falling down due to gravity. Okay, we know that the only charged particle that can move are the electrons. Okay, so here are the electrons. So what is going to happen? The electrons are actually going to be pushed up, or going to be forced to move up from the ground, okay, which is a series of neutral atoms. However, these electrons will notice that there are positive charges coming down, and they will be attracted to them. Okay, or the positive charges will be attracted to the negative electrons as they fall closer to the plant. Okay, so essentially we would get an excess of negative charges on the plant. Okay, so the answer to the question, which is state what charge appears on the plants as the droplets come near to them, negative charges appear on the plants as the droplets come near to them. Okay, that's the answer to that question. Right, next question. Explain fully how the plants themselves become fully charged. Okay, I've explained that basically the neutral atoms in the soil are made up of protons and negative electrons. The negative electrons are lighter and are placed on the outside of atoms, so therefore they move up or get attracted to the plant and basically move towards the positive charges of the pesticide or insecticide droplets. Okay, and that's basically how it happens. Okay, so just write that. The negative electrons from the soil are attracted to the positive insecticide droplets, causing both particles to move towards each other. Okay, so that's the answer to that question. Right, suggest 2 reasons why it is an advantage to both the farmer and the environment to use very small charged droplets during insecticide spraying. Okay, well, one reason is you use less insecticide, because that means it's more economical for the farmer. So if you think about it, okay, and I'm going to exaggerate this drawing, or these 2 drawings, that's the plant, those are the plants, sorry. If I had droplets like that, okay, that's extremely big compared to just dots like that, okay, these smaller dots are more likely to cover more surface area of the plant compared to these larger droplets, okay? And also, if you think about the wastage, okay, a bit obviously will fall on that leaf, however, a lot is going to fall to the ground. Whereas, if we have smaller droplets, more those droplets are actually going to be attracted towards the plant, and actually, due to their small size, are actually going to be spread out more equally, okay? So, actually, it means that the soil gets less insecticide, okay? So, it only goes in the plant. So, like, creatures living in the soil won't be affected by the insecticide as much, okay? So that's the other reason why it's beneficial for the environment, okay? So insecticide falls mainly on plants and does not affect other creatures. Okay, so something like that. Okay. Okay, so that is the sort of type of questions you get on static electricity. Right, next question. So, it says the circuit shows a battery connected to a switch and 3 identical lamps, L1, L2 and 3. Copy the diagram and add an arrow to show the conventional current, direction in the circuit, and when the switch is closed. So, I'm just gonna do that circuit for you. So here's my battery. So I've got a lamp here. This is L3. This is L2. Got another lamp here. This is L1. And here's my switch. Okay. Now, the longer side of the battery is going to be the positive end, and the shorter side is the minus end. Okay, so conventional current, when that is closed, is going to go this way. Okay, so that's conventional current. Okay, so that is the answer to that question. Next, a voltmeter V to measure the voltage across L1. Okay, so I'm going to actually put my voltmeter this way. I could have done it connected across this way, okay. But that's okay. So I've added my voltmeter. So we always measure it, place it across a component like this. Okay, so that we measure the potential difference or the voltage before it passes that electrical component and after it, and we see how much voltage gets lost. What's the difference between the 2 points? That's why it's called potential difference. Next thing, a switch labeled S that controls L3 only. Okay, so actually I'm going to put a switch here. Okay, I mean there should be a gap in between there, but that's my switch. Okay, and it will control L3 only because when that closes, current will go around this way and around this way. Okay, so technically I should have put it here. However, you should know from a previous video that actually electrons go from the negative end to the positive end. So I think both ways are acceptable. The main thing is you need to put your switch on this section of the circuit, okay, not down here, because if you put your switch down here, it's going to connect or affect lamp 2. So you need to make sure your switch is located on this branch, okay. I mean, in this case I should have done it here because we're talking about conventional current, okay, but from a electrical point of view, if you put a switch here and you keep that open, that is not going to go on, okay, no matter if that is closed, okay. Right, state and explain what effect adding another cell to the battery would have on the lamps in the circuit. Okay, so if we add another cell to this circuit, basically that's going to increase the chemical energy or the power that will be able to power up that lamp, and that lamp. So essentially the brightness of these bulbs will increase. Okay, so if an additional cell is added to the circuit, the bulbs will get brighter. Okay, so that's the answer to that question. Right, next question. So it says the circuit diagram shows a battery connected to 5 lamps. The current in lamps A and B are shown. Okay, there, 3 amperes and 2 amperes there. Write down the current flowing in lamp C and lamp E. So, how do we do this question? So I'll just do the circuit for you. A lamp here, a lamp there, 2 lamps down here, and another lamp here. And it tells us that 3 amps are passing through that. Lamp A through lamp B, 2 amps are passing through there. Lamp E is that, lamp C and lamp D. So, basically, there's this rule that states that current entering a junction, so 3 entering that junction, okay, when that junction comes back in on itself, it has to be 3 again. Okay, so no matter what the split is, it could be half and half. Now it would have been 1.5, 1.5 if we had 1 lamp there, or 2 lamps, 3 and 3. However, we've got 1 lamp here and 2 lamps here. So basically, the amount of current passing through here will be twice as less compared to the amount of amps passing through there. Okay, because the amount of lamps is sort of the resistance, or sort of like mountains. So this is twice as difficult as this route. That means twice as many electrons will pick the easy route, which is this route, and pass through this lamp compared to these 2 lamps. So the ratio is like a 2 to 1 ratio. So basically, if 2 amps are passing through there, we know that 1 amp has to pass through C, and 1 amp has to pass through D as well. Okay, and C and D are in series, so therefore the amps are going to be the same. Okay, so let's see, 2 amps joins up with 1 amp, so E is going to be 3 amps. Okay, so that's the answer to that question. Okay, so next question says, how much energy is transferred by a battery of EMF 4.5 volts when 1 coulomb of charge passes through it, okay? So EMF basically stands for electromotive force. It's essentially the voltage of a battery, or the maximum voltage of a battery that a battery theoretically should have if no current is drawn through it, okay? Anyway, basically it's a 4.5 volt battery, and 1 coulomb of charge passes through it, and what's the energy? So the equation you need to use is this equation. It's voltage, or potential difference, is equal to energy per unit charge, E over C. So in this case, E is going to equal V times C. 4.5 times 1 is 4.5 joules. Okay, or J. Next question. How much power is developed in a battery of EMF 4.5 volts when a current of 1 amp is passing through it? So we need to use this equation, or this triangle. Okay, power equals current times voltage. So I'm going to say power equals I times V, and that is equal to 1 amp times 4.5, and that is 4.5 joule, 4.5 watts. Okay, 4.5 watts is the answer. Okay, right. Next question. The diagram shows a circuit which contains 2 resistors. Calculate the total resistance of the 2 resistors in series. Okay, that's easy. It's just 4 plus 2. Okay, when we add series resistors in series, it's essentially just adding them like we add normal numbers. Okay, it's simple. So the answer is 6. The current flowing in the cell. Okay, so now we can use V equals I times R. So I'm going to use this equation. V equals I times R. We know that the voltage is 1.2 volts from the diagram. So V equals 1.2 volts. And our R total, which we've just worked out, which is the total resistance that the electrons have to overcome, or that the battery has to push around the circuit, is 6 ohms. Okay, that's 4 plus 2. Therefore, I is going to be V over R, which is 1.2 divided by 6, which is 0.2 amps. Okay, so we got 0.2 amps passing through the cell. Next question, calculate the current flowing in the 4 ohm resistance. So now we know that 0.2 amps is passing through the cell, and it's a series circuit. That means current is going to be the same throughout the series circuit. So it's asking us the current flowing through the 4 ohm resistor. It's also 0.2 amps passing through the 4 ohm resistor. Okay, it doesn't matter if it was the 4 ohm resistor or 2 ohm resistor, because it's in series, it's going to be the same current. Next question, calculate the reading of the voltmeter V. So the voltmeter V, here's my 4 ohm resistor, is actually, it's like that. We know 0.2 amps are passing through it. We know that V 4 ohms is the resistance at that particular point. So therefore, we're going to do the same equation, V equals I times R, but we're going to so we just need to substitute the numbers. So it's 0.2 times 4 is 0.8 volts. Okay? Next question. What is the power produced in the 4 ohm resistor? Okay, so this time we can use P equals I times V. So we know our current is 0.2, so 0.2 times 0.8 is 0.16 watts. Okay, so that's the answer to that question.